Assalamu alaikum. In today's lecture, we are going to study about the skin effect and starting from a brief explanation of electric and magnetic flux. Suppose we have two conductors. The first one is A and the second one is B. The charge on conductor A is QA and the charge on conductor B is QB. And I'm assuming that the conductor A has a positive charge and the conductor B has a negative charge. Now if I have to define the electric flux and magnetic flux, and more specifically if I am talking about the magnetic flux lines and the electric flux lines. So the electric flux lines will be originating from the positive to negative charge, originating from the positive charge and ending at the negative charge. So these will be the magnetic flux lines, and these lines are equipotential. And now if I have to draw the magnetic flux lines, this will be concentric around the conductors or the charges. So they will be concentric around the charges. So there will be magnetic flux lines concentric around both the charges. If I have to define the magnetic flux lines, so they will be forming the closed loops, and they will have two types. One is outside, as shown in the figure. So the magnetic flux lines are around the conductor or charge in concentric circles, and the other one is inside the conductor. So the changes in flux linking the conductor will produce or induce voltages in the conductor, right? So if I assume that there is a conductor and there are magnetic field lines inside the conductor, so there will be an assumption that there are some layers or filaments inside the conductor, right? So if I will be talking about the outermost filament, suppose this is your outermost filament, this is your filament number 1, and this is your innermost filament. Assume this is 4. So if I will be talking about if I am talking about the filament that is the outermost, which is the number 1 filament, the flux that is inside the conductor will not be linking with the filament number 1. So the flux linkage over the surface layer will be less than the flux linkage inside the conductor. So the flux linkage with the layer number 1 will be smaller, and the flux linkage with the inner layers will be greater. So the surface layer flux linkage will be less than the flux linkage of the inner layers. So as we know that the changes in flux will produce or induce voltage. So as we know that the voltage, induced voltage, is equal to N d phi by dt. So there are changes in flux as there is a changing current, alternating current, that will induce the flux that is changing. So there is a changing flux that will induce the voltage, and the inner layers have more changes in flux and more flux linkage. So there will be large voltage induced inside the conductor, or more specifically in the inner layers of the conductor. as the flux linkage in layer number 4 is larger, so d phi by dt will be larger, and due to large d phi by dt, voltage induced will be larger. By Lenz's law, we know that induced voltage will oppose the change of the current that is producing it, right? Induced voltage will oppose the changes of the current. That is actually producing it. As the induced voltage in layer number 4 is larger, so the current in the inner layers will be smaller, and as we move towards the outer layer, the current will increase, right? So this is the basic concept of skin effect. Just to revise it, as the flux linkage in the inner layers is larger, so d phi by dt that is being caused by the changing current will be larger, so V induced will be greater. So according to Lenz's law, this induced voltage will oppose the current that is causing it, so the current in the inner layer will be smaller. So this is the cause of skin effect. So large current density will be at the outer surface of the conductor rather than in the inner layers. And then there is another equation. We also know that L is equal to lambda by I. So if I apply this concept in conjunction with this one, so flux linkage at the center of the conductor is larger. So if flux linkage is larger, inductance is larger, and inductance is larger, then the inductive reactance is greater. So if the inductive reactance is greater, then the current through that portion of the conductor will be smaller, right? So this is a brief explanation of the skin effect. Thank you.